Hey, 10th grade, what's up? Hope you guys are doing well, staying safe. First of all, I want to take a minute to thank you guys for showing up to the virtual classroom on Thursday. The feedback that I got was really well, and I got the impression that most of you understood the material. Today, I'm actually going to give you the last topic of section 4.6, and then the next thing I'm going to upload is your review, because next week is going to be your final. And then that's it. We're done for the semester. Now, we are actually on page 278, example number 5, and we're going to talk about dividing complex numbers. Now, dividing complex numbers is very similar to multiplying complex numbers. In fact, we're still going to be using the FOIL method. It's just that instead of it being one multiplication problem, is actually a rational expression or a fraction. So this is example number 5 on page 278. It's going to be a real quick, short video. What are we supposed to do? Well, the example on page 278 says 7 plus 5i divided over 1 minus 4i. Now we all know that imaginary numbers, you can add them, you can subtract them, you can multiply them, you can FOIL them. Also, remember that imaginary numbers basically the square root of -1. Now you know that inside of a radical sign you can't have a negative number. So if you have something like this, that's actually an imaginary number. And I explained this in the class last week, but I just kind of wanted to take a minute and have you guys review that. So how do I solve this? What am I supposed to do? Well, it's like rationalizing the denominator. Remember when you had something like 1 minus the square root of 3 and you turn that into 1 plus the square root of 3? Well, it's the same thing. And for those of you that have no idea what I mean, this is what I mean. So if this is my denominator, I'm going to rationalize my denominator. And I'm going to multiply everything by the opposite of this denominator. So if this is 1 minus 4i, I'm going to multiply it by 1 plus 4i. Okay? And I'm going to do the same thing here. 1 plus 4i. So I'm actually going to FOIL my numerator, FOIL my denominator, and then that's it. So let's start with the denominator, or let's start with the numerator. So I'm going to multiply 7 times 1, which is 7. Then I'm going to multiply 7 times 4i, which is 28i. And then I'm going to multiply 5i times 1, which is 5i. And then 5i times 4i, which is plus 20i squared. And remember that I said that whenever you have I squared, it actually means -1. So in reality, this is actually 20 times -1. Okay, so 20i squared is actually 20 times -1. So we're going to FOIL the denominator and then simplify everything. So 1 times 1 is 1. 1 times plus 4i is plus 4i. 4i, or minus 4i times 1 is minus 4i. And then minus 4i times 4i is minus 16i squared. But again, it's the same thing as saying -16 times -1. Okay? Very simple. And now we simplify. So what do I simplify? And I know this looks like an equation for time travel, or, like some random, science particle or the speed of light, but really all you got to do is simplify it. So what I'm going to do is I'm going to work with my numerator, okay? So 7, there's really nothing I'm going to do with the 7, so I'm just going to bring it down. 28 plus 5 is actually 33, so that would be 33i. And then remember that 20i squared is the same thing as saying 20 times -1, which is actually -20. And I'm done with that. Now I'm going to work with my denominator. So 1 stays the same. And 4 minus 4 is 0, so I don't really need to do anything with that. And then you have -16 times -1, which is actually plus 16. So basically this cancels out. That's what happened. And then -16 times -1 is positive 16. And I'm still not done, but I'm almost there. So actually what I'm going to do now is just simplify it. And 7 minus 20 is -13. 33i, there's no like terms for it, so I just pass it on, plus 33i. And I'm going to work with my denominator, and 1 plus 16 is 17. Now, if I could simplify this fraction, I would, but if I look at everything, it's already in its simplest form. So your book actually says negative 13 over 17 plus 33i over 17. If you leave it expressed like this, or if you express it like this, it's actually the same thing. If you leave it expressed like this or like this, it's exactly the same thing. So it really doesn't matter, guys, how you leave it. Again, all I did was I multiplied. I FOILed everything. 1 times 1 is 1, which is where I got this one from. 1 times 4i is 4i. Negative 4i times 1 is negative 4i, or is 4i. And then 4i times 4i is minus 16i. So this cancels out because 4 minus 4 is 0. I drag over the 1. Negative 16i squared is the same thing as saying negative 16 times negative 1. Negative 16 times negative 1 is positive 16. And I'm done with that. So I'm going to do the same thing with my numerator. 7 times 1 is 7. 7 times 4i is 28i. 5 times 1 is 5, or 5i times 1 is 5i. And 5i times 4i is 20i squared. I can't do anything with the 7, so I drag it down here. 28 plus 5 is 33i, which is where I get this from. And then you have 20i squared, which is the same thing as saying 20 times negative 1, which is negative 20. Then you subtract 7 minus 20, which is negative 13. Pass over to 33i, and you have negative 13 plus 33i over 17, but you can actually write that as negative 13 over 17 plus 33i over 17, and since I can't simplify it, I leave it at that. And that's it. That's the example. That's the last example that we were missing from that section. So guys, what I want you to do is I want you to go to page 278, and I want you to work on problems 11 through 14. And that's it, guys. So this is your favorite teacher signing off. Stay safe. This week I'm going to upload your review. Next week is your math final, and then we'll be done with the semester, guys. So stay safe, and I'll see you soon.